Hey everyone, James McBride here again. Thanks for tuning in for our second unit. This is about the networking components that exist on our networks. And so we're going to talk about those basic network components that are out there. And this really helps you understand, okay, this is how a network and the internet function. So when people start talking about, oh, you need to do this to secure privacy, blah, blah, blah. For instance, we start talking about VPNs, then you really understand this is what the VPN's doing because you have these basics down. And so we're only really getting into the basic portions of a network. These devices would be found on any network. So they'd be found on a huge, massive one, or they'd be found right in your home. So we're going to take a look at what are we really doing here? Well, networking connects a bunch of different networks together. As a matter of fact, the term internet comes from an internetworking of a bunch of networks. So the internet is a collection of a bunch of private networks, not so lots of people say, oh, the internet should be free. Somebody's paying for this stuff. They're just making it available to you, and then you have to pay for access to it because that money has got to keep this thing going. So yeah, internet working of networks. So these devices are found across anything. Of course, part of the cyber safety is that some of this you do need to set up throughout your life. And understanding the basic components of it really helps you understand, oh, that's why I need to do that. So we're going to get into the transmission media, the network interface cards, and the differences between switches and routers, and then what firewalls are doing. And firewalls are such a big thing that we've got another unit coming up on firewalls. And that's really when we start to get into, okay, this isn't foundational information. This is, you need to be aware of this, and how do I protect myself? So that'll start in the next unit. All right, so network transmission media or medium, it's said both ways because in this sense it means the same thing. We used to have these things that we played music off of called compact discs. We had DVDs that we played movies off of them. This day and age, a lot of people are going around and getting those DVDs because they're afraid that these services will just stop showing these shows. So lots of people are collecting it. But that would be known as the media that the movie's on. So the DVD is the media that the movie's on. And we use that term media for everything. Oh, the media reports, right? That's a huge general term. That's why a lot of times I like to say medium, which is how do you connect to something else? What is the way? What's the pathway that's connecting through? But you'll hear both of those terms. And that is really like, are you connected Wi-Fi? Are you connected through an Ethernet cable? Are you connected through the cell? Are you doing satellite transmissions? That's all the media or medium that you're using to transmit and connect your computer to the outside world. What controls that? The fundamental thing that controls that is a network interface card, a NIC. And you have to have a different network interface card per connection. So if you have a wireless connection on your computer and a wired connection, or what they typically call an Ethernet connection, you have to have two NICs. So one to handle the transcoding or the manipulation of what the computer sees, how it formats data to convert that to the wireless network and how it needs to see that data. And the same thing for Ethernet. So those cards basically take information that is coming in and it's like, oh, okay, well, I need this formatted to go onto the Ethernet cable because it's not formatted that way. Your computer doesn't do that. Internally, the communications is different than externally, and it changes that around and sends it. We're going to take a look at an address that it's also giving you, and that's why they're saying an identification on the network. Switches and routers are totally different. This one is basically the life of the party. This one is the one that is not the life of the party. If you don't know what you want, it's not going to help you. And then we'll also really get into some firewall. Like I said, the next unit will cover firewalls in more detail. But here we're looking at it in adjacent to switches and routers and what they do. So routers will provide a connecting point between networks. And that's really the main thing people need to understand is when you're looking at these switches and routers, switches, they're for internal communications. Communications for devices internally in the network. Routers are for communication out of the network to another network. A firewall then is added on top of that router to further secure the communications and reduce risk. So we'll take a look at that. The core network hardware and media that we use. All right, so I talked about that wired NIC and Ethernet. Ethernet is a huge set of protocols. It's just a bunch of basically regulations and rules as to how things need to be formatted and done, and it's known as Ethernet to most people. And it describes this cable. This cable, like all this cable is an Ethernet cable. Looking at these, yep, these are all shielded Ethernet cables, a little more shielded than these. These are a little nicer. But anyway, they look a little different, but they're actually the same. It's fast, it's cost effective, but it's usually just for local networks. The communication length between this is about 325 feet, about 200 meters. And that's how far the signal is going to go with Ethernet. But it's very, very fast. It's much faster than Wi-Fi, actually. Wi-Fi is basically an adaptation of Ethernet, and it puts it on the radio waves. So radio signals, like when they say, oh, we're using radar, radio signals are used for that. You connect to a satellite, radio signals. You connect to a cell network, radio signals. You connect to a Wi-Fi network, radio signals. And they're all different types of radio signals. Wi-Fi, this term means wireless fidelity, and it's been used forever. And at some point, it just became the de facto standard for when we want to say we're connecting to a local network, it's Wi-Fi that you're doing that through. And so it's a broader term that in my world is a little more marketing than anything. All right, so a NIC that's using Ethernet plugs straight in like this. A NIC using wireless technology or Wi-Fi means it's sending out radio waves through the air. So the air becomes the media or the medium. Now, just to mention, like special note, high-speed fiber optics. What other speed would be fiber optics? Fiber optics is fast. Optics, meaning it's light. It's actually a light impulse. They use different modes of light, so they can use red, blue, green. They can use all these different modes. And the light is used to transmit the data, so it's super, super fast. The cable that they use is fiber optic cable. The reason they say it's fiber is because it is as thin as a fiber. It's as thin as a human hair that actually sends the data. It's much faster than Ethernet. It can go miles and miles and miles. As a matter of fact, they lay it in the ocean to have internet from continental United States to Japan and China, and continental United States to Europe and Africa and all that. There's fiber laid in the oceans all over the world, and it's super, super fast, and it can carry a ton of data. So normally you're not going to have a fiber optics connection, like something like this on your computer. There was a push for that many, many years ago, but usually what happens is the fiber optics comes to the building, and then it's wired Ethernet and Wi-Fi, both of those. All right, let's talk a little more in detail about this interface card. Let's get into what a MAC address is. MAC stands for Media Access Control, or how I access the media. And it gives you a specific number, and that number is unique on that network. And every single card, so Wi-Fi or Ethernet, has a MAC address associated with it. And it's hard to change that MAC address. It's normally what we would call permanent. It doesn't change. It's always the same. And it's a bunch of letters and numbers. So it's not just ones and zeros. It's not just a 0 through 9. It's also A, B, C, D, E, F is part of that. And it identifies that particular interface card. So here it says devices. It identifies devices. Well, in a broader sense, you tie into Wi-Fi down at McDonald's, and you're talking to the router. This MAC address is used to send data from you to their Wi-Fi router. That's what's happening. You really have to think of it this way. How do you get mail? How could you possibly get Amazon Prime to send you stuff that is going to come to you? Well, there's an address that you have to tell them. Otherwise, that's not going to get to you. And two people can't have the same address. Well, obviously they can if they're living in the same building. But what I mean is that there's 4 million James McBrides in the world. It's a pretty common name. They can't say James McBride, same address as me. Otherwise, I get their packages. It would have to be James McBride, totally different address. Me, totally different address. And so that's what these MAC addresses really provide. It is no different than you saying, well, I have a phone number. These days, people don't even look at phone numbers, but you just say, call my friend, and your phone calls. But behind that name, there's an actual phone number. And if your friend changes their phone number and you didn't change it in your phone and you say, call my friend, it either isn't going to connect to them or it'll connect to somebody totally different. You'd be like, who's this? Right. So it's using the phone numbers. This phone number wants to talk to this phone number. Now we go. Same thing here. This MAC address wants to talk to this MAC address. Now we go. That's what the MAC addresses do for us. All right. Let's take a look at the devices that manage all this traffic and how we really start to connect to the internet. The first one we have is a switch. A switch is really for, as I said, a local area network, just your network. You're on EAC's network, that's their LAN, and your device, whether or not it's your phone or your tablet or your PC, is going to have a MAC address. It's going to hit the switch, and you're going to say, hey, switch, I need to talk to the printer that's in the same room. And the switch is going to go, oh, I know that printer. So there you go, you're connected. I know both those MAC addresses. There you go. You can communicate now. Again, switch life of the party. You walk into the party and you say, hey, James, do you know where Joe is? And I'm the life of the party. So I go, oh, yeah, Joe's over there. Yeah. Hey, you don't know Fred too? Well, yeah, he's not here right now. Yeah, he does this and this and that. The life of the party seems to know everybody. So that's what the switch is doing. It is designed to connect everybody that's there in that local area that's right there. And it uses these MAC addresses to figure out how to connect them. Now, what it does, well, in performance, it handles all that local traffic, so routers don't have to do any of that. The only things that will go to a router are the ones that I need to get out of this network. I need to go someplace else, not here. And that will then be forwarded from the switch to the router, and then we'll talk about them and what they do. All right, but security considerations. I threw this in because, I might get people that are going to run their own business or have their own business. And I can tell you, because I teach security, I look for this stuff. And I don't know how many places I've walked into, not just this valley, but wherever. And there's switches just sitting there. It's like I can touch it while I'm talking to him. It's just right there. What that means is because the switch is the life of the party and wants to talk to everybody, if I'm a hacker, I can actually plug a little device in that switch. And I'm going to assume, as a hacker, that because the switch is just sitting there out in the open, not protected at all, that you don't know that that can happen. So you won't even look and ever see it. And I can plug that device in, and now I can leave and I can go outside and I can see everything on your network and I can try to start saying, well, what are they printing? Hey, that's the database server. I bet you have a bunch of credit card information on that. I might even be able to hack their accounts and actually transfer money from their accounts because I'm on this switch now. And so where you place this physically in order to make sure it's secure is extremely important. I mean, even if you're like, I have to leave it here, this is what it's supposed to do. I've got to connect these 10 selling machines right here. Well, they make little plastic boxes that at least go over them so that somebody can't just jack right into it and do what they want to do. Protect that stuff. All right, let's take a look at a router. So let's look at the routers. We'll talk about that term gateway in just a minute. But a router is not the life of the party. It is the opposite of that. If you don't know what you want, it can't help you. So you can't walk up to it and say, "Hey, do you know where Joe is?" It just ignores you. No, I don't. It's just going to stare at you. I don't know where Joe is. Joe could be right there, but it's not going to tell you. So you have to know what you want. You have to know your computer comes on, you launch Chrome, it goes to Google. That traffic then, with your MAC addresses, hits the switch. The switch says you need to talk to the router. It sends it to the router. Now another number is used that we'll talk about in a minute. And the router says, "Oh, you need to go to Google. I know where that is." And it sends you there. But if you just come up and say, "You know what, router, I don't really know what I'm looking for," then the router just ignores your transmission. It doesn't care. It won't listen to you. Now, in home networks, this is not common in business networks, but in home networks, those little tiny wireless router access points, or what people call wireless routers for short, that's the marketing term, they actually also hand out IP numbers. So we're going to look at what IP is doing here, but DHCP is Dynamic Host Configuration Protocol, and basically your computer, your phone attaches to the network and says, I got a MAC address. Here's my MAC address. I know I got a MAC address. Here it is. And the system goes, "Hey, thanks." Then it says, "But I need to get on the internet, and I can't do that without this IP address." And it says, "Oh, well, I can dynamically configure that for you. Here's an IP address." And it gives your phone an IP address, and now you can talk on the internet. Most home networks, that's the way it works. That little tiny wireless box with the antennas on it also hands out these IP addresses. And so routers spend a ton of time managing that traffic that's coming in and out. Everything coming in and out of your network has to go through the router. Everything. So that's why if you go out and you're going to buy a home router and you're looking, it's like, why is this one $60 and that one's $280? Well, a major reason why is not just all the added technology that they put on it, but traffic management. How fast can it send that in and out of the network is really important. And a lot of people won't do that. They'll just say, "Oh, well, I'll get this cheap one because it says it's Wi-Fi 6, and this really expensive one says Wi-Fi 6. So all I need is they said Wi-Fi 6. I'm good to go." Oh, yeah, you are. If there's two or three of you, you'll be fine. You're just streaming one device or two devices, getting on YouTube and stuff, you'll be fine. But then once you have 8 or 9 people, like maybe you're in an apartment complex and you get to know the people next door and you're like, "Oh, I gotta use my Wi-Fi." Now it's going to start to bog down because the router deals with this traffic management. And the more traffic you got going through there, the harder it's going to be on that router. So this is where the term gateway comes in. Way back in the day, we don't really think of it like this, but the internet was born in 1969. So by the time you get to about 1975, they're really doing some development on ARPANET, which is the internet. It's basically what the internet was back then. And they had a mini computer. You can look that up, and it's the size of a refrigerator, basically. And they had mainframe computers. Now, the PCs were just starting to happen. So how do you get to the internet? Well, there was no router. There wasn't a device for that. What you did was they connected that mini computer to another mini computer using telephone lines. So one mini computer connected to another mini computer connected to another one, and that's how it made it. Well, so the term router didn't exist because you really weren't routing traffic. You weren't taking internal information and routing it through that machine. Instead, that machine was a gateway. Now, why this is important to understand is because they have kept this term. If you ever have to set up something statically assigned IP addresses, you will see your IP, you'll see a subnet mask that you have to enter, and then there's this gateway. And man, that confuses people because it's like, what's a gateway? Do I have a gateway? I don't know if I do. I think Gateway used to be a computer company, weren't they? It's confusing. So really what that means, gateway is router. What's the router's address? And they call it a gateway because that's what they called it all those many, 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 many years ago. And they've just kept it. We do that as a society, don't we? All right, so let's talk a little bit about firewalls, and then we'll get to the addressing. So you understand a little bit about that addressing, and then that'll be it for this unit. And this unit, yeah, has a lot of technical stuff in it. I would say it's the hardest unit because you're a little bit removed. The next units are this is what you do for privacy, this is what you do for security. This one is like this is the foundation of what those are sitting on. So, all right, so firewall. What is a firewall? Firewall is a brick wall. They put it in buildings so that the fire won't shoot up the side of the buildings and burn everything to the ground. Back in the 1800s, not joking, lots of people died in New York. Somewhere on the uh, third floor, a fire starts. It goes all the way across the third floor. Then when it gets to the side, what does it do? Well, most of us never think about this. These are old brick buildings, right? These are old brick. How did they put things in the building? Well, they just pushed into the sides wood, wood beams that support everything. And what that meant is the fire would go all the way across that floor and then it would go up the sides of the building. And then basically in a few seconds, you now have lit fire to every floor above that. And nobody gets out. Everybody burns. It was very tragic. So what they started to do was, hey, how could we stop that from happening? Well, in between the brick wall and the inside wood wall, where this is burning up through, let's push the brick out from the wall. And then what will happen is when the fire tries to come up, it hits this firewall. It just hits a wall. And yeah, you're not going to be protected forever, but it's really going to slow down the burning of the building. It'll take longer. And that's where firewall came from. They also use them in vehicles because if the engine's really hot, you really don't want your legs near the engine. So there's a wall there and it's a firewall, except it's obviously not brick. Yeah. And these days, of course, they use other materials, but that's why you always see this as a brick wall. It goes back to that. It's a very, very great visionary term to use for what this thing does. It keeps the madness of the internet from getting into your system. That's what firewalls do. They protect networks by filtering traffic. It can be a hardware firewall or a software firewall. And yes, there are some routers that have some firewall features. And technically speaking, a router is a firewall. It's just not as advanced as the newer stuff. So what do? Well, the firewall actually looks at the traffic. It looks at where it's coming from, where it's going to, and the type of data that's in it. And then it can block it or allow it depending on rules that are set up. So this firewall becomes extremely, extremely important and usually is at home, is built in to your normal stuff here. Let me take a look here. There we go. Come over here to Brave. Basic home diagram. This is the internet. That's the cloud. This is your ISPs, router, modem. Sometimes this is split, right? Sometimes you have a wireless modem, and then there's a router. Sorry, not a router, a modem. This is your wireless router. This is your wireless router, and you have a modem. Sometimes those devices are split. Sometimes they're not. It just really depends. That's one of the reasons why it's important to understand what is this modem doing? What is the Wi-Fi doing? What is a firewall doing? So you understand this is the device I have. It has all of it combined. Now, we haven't really talked about a modem, and we don't really need to talk about it too much. A modem is a modulator, demodulator, and basically it just interprets the internal network and converts it to what your ISP needs. So it might be a cable modem, it might be fiber optic, it might be cell. All these basically what's happening is you got one technology, which is Wi-Fi here or Ethernet, and that has to be converted yet again to something that your ISP can understand. So sometimes those are split. So you got some wireless happening here. and you got some wired happening here. They're wired into this, and this is also the firewall. So your little home router is a firewall as well. All right, so let's take a look at addressing. Computers have to have identifiers, as we talked about. So that's kind of summing up that you got to have a MAC address, you have to have an IP address. But why do we need both? What's going on here? Why is there two numbers here? There's actually more numbers than two, but these are the most important ones. So a MAC address is for your local communication. Your IP address is for internet communication. We have no way on a MAC address to actually show what part of a network you are in. So when you actually connect into, say, EAC's Wi-Fi on your phone, it needs the MAC address. And now you can communicate in EAC's network with no problem. But that's usually not what we do. We want to get on the internet. I want to get to Netflix. Thank you very much. Well, there's nothing in the MAC address that really tells Netflix where the heck you are. And so if it tried to use a MAC address alone, Netflix would go, okay, I'm going to send it back. I hope somebody remembers where you are because there's nothing in this MAC address that tells anybody anything. IP addresses, on the other hand, do. So you basically have this IP address so you can say, I want to talk to Netflix. And then once that information comes back to your firewall router, the firewall router goes, I know your IP, but in order to actually speak to you directly, because I've got to use this switch, here's the MAC address. So it's using both of these numbers all the time. We already talked about the purpose. Real world comparison, again, is just like having addresses for your mail or calling people. And then you use both of these. Or you use both of those addresses. Oh, whoops. See, this MAC address is a permanent name, and it's part of every single device. The MAC address is embedded during the manufacturing, and it does not change ever. So that's the problem. We cannot give you the location because how can we identify that in the MAC address? And the MAC addresses help networks recognize devices. Who are you? This is where the switch comes in. So the switch is using all these MAC addresses. It figures out who's who, and it sends the data back and forth, which is great. IP addresses, they tell where the device is located on the internet at that moment. Again, you can take your computer with that MAC address that doesn't change, go down to McDonald's, use Mic Wi-Fi, and now your IP address will be different, but your MAC address will stay the same. Unlike MAC addresses, IP addresses change depending on their network connection, and IP addresses help the internet know where to send the information. MAC addresses are not part of that. Let's see. Those are, this is a good comparison. MAC addresses show who you are, IPs show where you are. So that's really the main difference between them. And let's take a look at what an IP address looks like just briefly, just so you can see what IP4 and 6 look like. But basically, that's the difference. You've got to have both of them. There's no way you're ever going to communicate on the internet without a MAC address because the local network will not know how to get you that information. As a matter of fact, it won't even talk to you. The local network has to use this MAC address. There's no way you're getting on the internet without an IP address because there's no way for them to know how to ever get it back to you. And so you have to have that IP showing your location. All right, let me switch over to Brave here. Use several different browsers, and we will look up IP version 4 address. IP version 4, we're not going to get into all those technicalities of, what it's doing and what it's not doing and the fact that it's really old. We just want you to see what it looks like. So an IP4 address looks like this. You basically have what they call an octet separated by these decimals or dots. And these numbers can go from 1 to 254. Mathematically, it can go from 0 to 255, but usually 1 to 254. Your typical home network is going to use, not that. I thought they would show me a default. I'll have to go back to all. That way I can get the AI to show you. But typical home network is 169, I mean 192, 168, and then this is usually a 1. So 192, 168, 1, and then whatever number it's going to be. So 192, 168, 1, router is usually 1. Now, the reason I'm just mentioning this is not on the test. Some of you have faded out and stopped watching, but I'm going to actually show you, hey, this is how you administer a wireless router. And so you got to know, why are you typing in these numbers? So IP4 is usually how we're still doing that, even though it's really old. And then IP6 is looks much more confusing, but actually is much more automatic. And I may add a video in on this, maybe not. But yeah, it's big. It's a big number. I was going to look in. This is some nice explanations. So yeah, this is an IP6 address. It's like, wow, that's a huge number. It looks so complicated, but almost all of this is automatic, and you don't actually have to type in this whole number to do things like look up things or anything. So IP6 looks more complicated, which it is, but because it's more automatic, it does a ton of stuff for you that you do not have to worry about. All right, so that is it for probably the most advanced chapter that we're going to actually take a look at. So thanks for sticking with me, and move on to the study guide and prep for that test. We'll talk to you later.